Hello, my name is Gaurang Jagtap. I'm studying software engineering from University of Westminster. This is a demonstration video of my software engineering final project. My topic is end-to-end software development lifecycle automation using platform-based approach. Let's start the demonstration video. Before we get into the CICD library framework, let me show you how it works in action. In order to save time, I have already deployed a suite of applications to demonstrate a full potential of CICD library framework. I have built a simple bookstore application, and this application has been developed using Node.js, React.js, and Mongo as a database for storing the book records. So right now I have six repositories in my project. So this is responsible for backend operations. This from this admin we can perform our admin operations like CRUD operation, and this is where the user can see the application. So this is the bookstore user I have, and where user can browse the books and can check the details of the book. This is all about bookstore, and this is my backend API which is connected to Mongo, and where we can fetch all the data. And this is my front-end application too. This is admin dashboard. Right now we have 19 books in our bookstore, and this is a list of bookstore we have. I am gonna perform a CRUD operation, so let's edit. Okay, let's edit this book so we can see the details of this book. And what we are doing is, okay, I'll just copy the author name and I will paste here, and I'll update the book. Okay, so now I have updated the book. Now it should reflect on my bookstore user web application as we refresh this. Okay, so the update has been reflected on this application. In order to show how this framework makes developer life easy, I'm going to make a simple change to the code base. So I'm going to change the title of the bookstore, which is now Westminster, my component, and I will go to naba.js. So here my title is Westminster Bookstore. We will change this to found the problem. Okay, now I'm going to change the directory. This is bookstore user, and I'll check the git status. Yeah, it says that the source component neighbor file is modified. Now to say git add, git commit, and push. So as soon as the change is made, the CI pipeline should build a container image, and the CD pipeline should deploy the image in Azure Container App. Once the deployment is successfully done, we should be able to see the changes live. So now I'll push the changes. So it has done. So now we'll go to GitLab, and this is my DevOps project, and I will go to bookstore user. As we can see, the pipeline is running. If you go to, so this is our pipeline. So, and these are the dependencies. So I'll tell you, this is my validate. So right now we have 5 jobs, and this is validate. So in this stage, the code is getting validate and through prettier and ESLint, and after that it will get testing. after the testing process, it will go to the next stage, which is build. So in this build stage, the image will get pulled from the Docker hub and it will get pushed to container registry. So now, as you can see, this has been done. Now the build process is running, and after that it will go to the next stage, which is plan. In this stage, the Terraform will get initiate, and it will get initiate and it will run the Terraform plan command. And after running the plan command, the Terraform will form a resource group and it will form a container environment. And as per our main.terraform file, it will form a container app as well. So right now it is running the build stage. What we are trying to achieve here is how just one commit results in building and deployment of the code without any manual intervention. Now, as you can see, the planning stage is also completed. So we just have to hit the apply button. So I have write a script for the manual action, but we can also change the script and automate this process. So we'll start the application. Now, as you can see, the apply stage is also completed. We should see the changes on our web application. So we'll go to web application. So here is it. And as we refresh it, we should see the change. Currently, I have made a deployment of serverless application possible using CICD library, but this library could be extended for deploying application on any suitable environment or cloud. Let me walk through the serverless setup on Azure. So I have utilized the container app service for deploying bookstore apps. The entire infrastructure creation and deployment is automatic, meaning no manual intervention is required for the provisioning of cloud resources. First, we have created a resource group. So we have this book manager resource group, and next, in order to hold all the bookstore apps together, environment is created, which is book app environment. Within the environment, we have all the application here. So this is our Mongo, this is admin, bookstore admin, this is backend, and this is bookstore user. So now that we have looked at the serverless setup, imagine that a team would like to stop or destroy the application. How would they do? So now for that, we have to go back to our pipeline where previously I showed how the pipeline is running. So over here, you can see we have this is a user application. So this is the pipeline for the user application, and we'll hit on the destroy job, and as I hit on the destroy job, now it is running. CICD library also expose a feature called destroy that helps user to kill all the resources at click of a button. So this is the user app. So an individual app can be killed by going through the pipeline through which the application was deployed. So the destroy is running. So as I can see, this is the GitLab terminal. See, as you can see, the destroy complete resource 1 destroyed, and the job is succeeded, as you can see here. So now that the job has finished, let's go to Azure portal again and see if the container has been destroyed or not. So I will refresh this here, and in case we have to deploy the app again, we would go to the same pipeline over here. Let me walk let me walk through the shared pipeline. Before going to the shared pipeline repository, I'll show you. This is the YML file for my bookstore user. So if I clicked here, as you can see, I have included the other repository file over here. So this I have included the shared pipeline repository, and the file is gitlab ci.yml, and these are the default and these are the variables. So if you go here in the shared pipeline, so this is the gitlab ci.yml file. As I open this file, you can see I have included the other files in this file. So I have not directly written the CI pipeline code over here. So I am including the local CI main.yaml and CD main.yaml. CI is continuous integration and CD is continuous development. And the stages are validate, deploy, and build. So if we go back to shared pipeline, you can see CI. So in continuous integration, I have included the main.yaml. And even here, I haven't directly wrote the pipeline code. I have included for validation, I have included the validate main.yaml, and for building, build main.yaml file. So if you go back here, so as you can see, this is build and this is validate. And over here, actually we are here, okay. So, and same goes to continuous deployment. And this is my infrastructure foundation. So over here, so this is our infra file, which is responsible for initializing Terraform and then forming Terraform module and then creating a resource group on the Azure portal, then creating an environment, and after that it will deploy the container application in that environment. So this is how the shared pipeline or shared library work for continuous development, continuous integration, and for infrastructure. Now let's understand the CICD in detail. So as you can see in this diagram, every application has built their own CICD pipeline. This gives more flexibility to the developer in terms of how they would like to shape their software building and deployment process. A major disadvantage of this process is organization cannot introduce a common feature such as security scan to all the app at one go. Rather, each app will have to update their pipeline code to implement the feature. And another disadvantage is duplication of the common code across many apps. When each application team is required to write their own pipeline, onboarding of the application, so the application also delayed, which in turn delay in delivery of the software to the end customer. Okay, now let's take a look at our CI/CD library approach. In this approach, the development team can take advantage of DevOps platform scripts or CI/CD library framework to build their CI/CD pipeline. Teams can configure CI/CD in a matter of few minutes. Before I show you how this can be done, in a typical setup where such framework is used, the team would reference CI/CD library file in pipeline file. Next, they would specify the specify which programming language they have written in their application. Finally, they just need specify how would they like to deploy their application. Just few lines and job done. Under the bonnet, CICD library exposed various functionality with the use of variable. For example, if a team has developed their app in Node.js, they would have to specify Node.js as their technology. The library detects the value instruct itself to run the stages that are responsible for building Node.js application. Currently, this library supports Node.js and React.js application. But if a team wants to build a .NET application, we can do it by simply extending this library to include stage for next application. Similarly, this script can be extended for any environment such as Kubernetes virtual machine deployment, and in case app needs to be deployed on AWS or GCP, even that can be made possible by extending the library provision resource on those respective clouds. The demo we had for Bookstore app has successfully utilized this approach to manage CI and CD.